Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of n plus 9 to the power of n plus 27 to the power of n is equals to 14, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, here we can write 3 to the power of n plus we write this 9 as 3 square and its whole power n, plus we write this 27 as 3 cubed and its whole power n is equals to 14. And after this step we will use here the nice exponential law here, and you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m. It means that we will just interchange these exponents and it will gives the same answer. So now here we need to change these two exponents, so that we will write it here 3 to the power of n plus 3 to the power of n and its whole square plus 3 to the power of n and its whole cubed is equals to 14. And after this step we will we need to convert this nice exponential equation into the cubic form, so that here we will just take y is equals to 3 to the power of n. So when we take y is equals to 3 to the power of n, then this equation will becomes y plus y square plus y cubed, and this whole equation is equals to 14. And now you can see here this nice equation will becomes in cubic form. And now first I can rearrange these terms, and we will write it as y cubed plus y squared plus y minus 14 is equals to 0. And now we can again rewrite these equations as, here you have y cubed plus y square, and we will write this plus y square as minus 2y square plus 3y square, and here you have plus y and we will write it as minus 6y and plus 7y minus 14 is equals to 0. So in this way we will find the factors of this nice cubic equation, so that here first we need to take common here y square on these two terms, and you will get here y square into y minus 2, and plus here we take common 3y and we get y minus 2, and here we take common plus 7 and we get y minus 2 is equals to 0. And now you can focus on all the terms, and you see here y minus 2 present on each term, so that we will take common y minus 2 here, and you will get y square plus 3y plus 7 is equals to 0. So that here we have two cases. The first case is we take y minus 2 is equal to 0, and the other case is we take y square plus 3y plus 7 is equals to 0. So in this case you get the value of y is equals to 2. And now in this nice quadratic equation, now first we will check that is this quadratic equation has real roots or not, because in this problem I can just solve this problem for the real roots only. So that first I can check this quadratic equation has real roots or not by using the nice discriminant formula. So that here you have a is equals to 1, b is equals to 3, and c is equals to 7. And our discriminant formula is, so disk is equals to b squared minus 4 times of ac. So now I can little bit explain this discriminant formula, and you know that if this delta is discriminant is less than 0, then we say that this quadratic equation has no real root. And if this delta is greater than 0, then we can say that this quadratic equation has two real roots. Similarly, if this discriminant is equals to 0, then we say that this quadratic equation has only one real root. So now we will check the behavior of this discriminant by putting the values of a, b and c here. So you get it in this form. Discriminant is equals to b square, and b is 3 square minus 4 times of a is 1 and c is 7. So 3 square is 9 minus 4 times of 7 is 28, and it is equals to minus 19. And you see that this minus 19 is less than 0. So if minus 19 is less than 0, then it follows this case. So in this case we will just say that it has no real root, and if it has no real root, then we will reject it this case, because in this problem we will need only the real roots. So now we can just proceed here this case only, and in this case we have y is equals to 2, and in the start of the problem we will write here y is equals to 3 to the power of n. So now we can back substitute the value of y here, and you will get 3 to the power of n is equals to 2. And now in order to find the value of this log, we will take the natural log on both of the sides, so that it will becomes log of 3 to the power of n is equals to log 2. And now we can apply the property of log, and we move this exponent in the front of this log, and you will get here n times of log 3 is equals to log 2. And now in the next step we move this log 3 in the right hand side, and you will get here n is equals to log 2 over log 3. And you can use the calculator in order to find the value of log 2 and log 3, and you know that the value of log 2 is 0.3010, and the value of log 3 is 0.4771. And now we can again divide both of the terms, and you will get the value of n is equals to 0.6308. So this is our final conclusion of this problem, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.